Hello everyone, good afternoon. Just a minute. Okay. So dear authors and invited guests, welcome to the technical session 1B. Myself, Deepika Jain, I would be the host of this session. The session will be moderated by me. And so on behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Conference on ICT for Sustainable Development, that is ICT4SD 2023, Goa, India. The 8th edition of this conference has been organized in a hybrid mode and physical mode as well. The physical conference is being held in Goa on 3rd August, and the virtual event is being held on 3rd August and the 4th August. Yeah, I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be getting 8 minutes for the presentation and 2 minutes for the question and answers. Yeah, please be aware of the time schedule as we have parallel sessions continuously. So we do not want any delay in the further sessions. Okay, so I will be giving a time check when at the end of 8 minutes. And there is another request for the participant to be connected with us till the end of the session. And if you have any queries, just drop me a message in the chat forum. Okay, just before we get started, just a minute. I would like to introduce you to our session chair, that is Professor Astha Parekh. She is a senior assistant professor in the Department of Computer Science at IIS, deemed to be University Jaipur since March 2010. Her research interests lie in the area of programming languages, data mining, cloud computing, and sentiment analysis. I welcome you, ma'am, for the session.
Thank you, ma'am.
Yeah. So I hope all the participants are here. We shall start our first presentation. Do we have Richard here?
Yes, I'm here.
Yeah, all right. Here you are presenting a paper on multi-layered secure image steganography technique, resistance to regular singular stegananalysis attacks using elliptic curve cryptography and genetic algorithm. Can you you can start sharing your screen?
I hope my screen can be seen.
Yes, your screen is visible and you're audible as well. You can start.
Okay. So good morning. I'm currently in the UK. So it's actually a morning here. And good afternoon to those also in India. You are welcome to the session. So my session, as you rightly mentioned, will look at a multi-layered secure image steganography techniques capable of resisting regular singular stega analysis attacks. And we use elliptic curve cryptography and then genetic algorithm. So we are actually 4 authors, myself, one James Benefonakwa, Michael Asante and Chum. So I am presenting on behalf of the team. So basically, this is the outline of my presentation. We'll look at some basic introduction, the problem, the objective behind our work, the methodology we adapted, the results we came out with, and then the conclusions and the suggestions. Indeed, all of us must have noticed that during COVID-19 and even after, there has been an increase in cyber attacks. And basically, organizations have tried as much as possible to see how best we can reduce some of these data breaches. Even before the attack, we realized the increasing use of cryptography and steg in trying to protect data. However, the challenges has been that the cryptography, which is supposed to provide the data security, came under heavy attack because cyber criminals and attackers began to use an opposite technology of the steganography to begin to reveal data that is being transmitted in communication. So in effect, whilst we are trying to provide confidentiality, integrity, and availability of data, attackers were also aimed at trying to reveal and breaking the confidentiality requirement. I mean, there are so many steg analysis attacks out there, but a key of them here is what we call the regular singular attack. It is actually a statistical attack that tries to identify a message, detect the message, and estimate the length of the message that is within it. Now, so if this attack is there, the implication, however, is that for a secure communication to take place and for data confidentiality to be achieved, or what I popularly refer to as the CIA triad, then there is a need to ensure that every method that is aimed at protecting the data will be able to withstand RS data analysis attacks. This is because just as we are trying to provide a secure means of communication, attackers are also developing very high sophisticated techniques that they use to estimate communication. The requirement, therefore, is that a more robust systems have to be developed. And indeed, the literature is actually undated with some of the existing methodology. But the question then is, if there are methods, why then do we also have to come out with it? So what is the problem that currently exists? Throughout our literature review, we noticed that issues of double frequencies, false positive and 0 points, and sometimes also the challenge of the trade-off between providing high embedding capacity and achieving security. And here by security, we mean the imperceptibility of the image that is being used to save the data, and then also the robustness of the system are challenged, such that it becomes visually possible for people to identify that this image that is being transmitted on the internet contains some data. And so they will do further analysis to actually check which data is in it. So this has been the challenge of the existing system. Now, our main objective, therefore, was to improve the imperceptibility here, so that it means that the security will have to be improved. And by doing so, the visual quality of the stego image, and here stego image is used as the result of hiding the intended message within a cover image. So the outcome of that process, we get a stego image. And so we try to compare the quality of the image without the message to the quality of the message after the message. So the results of this process will be that we would want to minimize MSC, which we call the mean square error, and then we would have to maximize PNSR, which is called the peak signal to noise ratio. I mean, these two are parts of the evaluation metrics that are being used to evaluate the performance of STEG applications, whether being image, audio, and all that. And so specifically, this paper is based on image steganography, given that there are so many other types of steganography. And so this is also with the view of providing a robust measures against RS attack. And so our application or our technique is in so many layers. So basically, you realize that there are 4 iterative processes that we follow in this method. All of them aim at achieving the security together. And so the first process that we use is a cryptographic process. And here we use the public key crypto infrastructure. And the specific one that we try to implement here is what we call the elliptic curve cryptography. And so I shorten it called the ECC. the ECC has its own advantage vis-a-vis other comparative method like the RSA. Here, it means that we can achieve the same level of security even with less amount of key, because the more the key size, it means that the efficiency of the algorithm in terms of the throughput will take a lot of times to be efficient or perform. Then STEG embedding process, actually, basically, there are three ways for which we can embed data. It's either we are using the special domain, or either we are using the transform domain, or now there was what we call the adaptive, where we try to combine the two. So specifically, we use the spatial domain, which is the least significant bit insertion algorithm. That's what we use to embed the data into the image. And when that is done, we use the genetic algorithm, try to adjust the pixel values to ensure that the message that we have embedded is actually in a location that will become very difficult to find. And then when we finish, we did what we call the RS analysis using mathematical model to estimate the performance of the algorithm. And so the performance of algorithm use some standard methods. I have mentioned one, which is the MS mean square error. We also estimated the peak signal to noise ratio, which is the PSNR. We actually also try to look at the capacity of the algorithm by trying to look at the bits per pixel. How many bits are we able to insert in each of the pixels of the cover image? Then we also have what we call the Pearson correlation coefficient. That is also done, calculated, to be able to measure the difference between the cover image pixels and the stego image pixels. So this flow chart demonstrates the processes that we went through, including the three main operators of the genetic algorithm, which is actually the selection process, or what we call the reproduction, the crossover process, or what sometimes people also call it the sexual recombination, and then the mutation process, which sometimes I call it the gene diversity. So basically, the strength of the algorithm now has to be on this biological process of genetic algorithm, because the genetic algorithm is based on the principles of genetics, which Darwin introduced as survival of the fittest. And so this is the complete process that the system goes through. Then at the end of the day, we calculate the RS resource of the system. If the RS resource is determined that it is less than 5%.
Dear presenter, I think you have crossed the time. Please conclude soon.
Okay. And so as part of the experimental results, we try to use this linear image to look at the various measures. And you can see that on this screen, the results before our system was applied can be seen from there. So basically, this result shows the various measures that we use. And then we could see that our system was compared with 5 other systems, except the Lu and the Ho measure. We try to be a bit higher than ours. In terms of the PSNR, our value when compared to other methods was far better than 3 other methods that was existent. So basically, the requirement for PSNR is actually 36 decibels, and we were able to achieve 50.3 decibels. And so our system has provided some enhanced methodology. This is the work in progress. So we intend to actually improve on the algorithm by increasing the peak signal to noise ratio in the next method, and also to ensure that the capacity is enhanced by trying to have this system achieve actually 3 bits per pixel. We intend to achieve 4 bits per pixel. Thank you very much.
Thank you for your presentation. Thank you for your presentation. Any questions, ma'am?
Yeah. Come to the table, please, Richard.
Doc, please come again.
Explain the table, the proposed method table.
Okay.
Yeah.
Yes. Yes. So here we have the first column is actually the embedding rate.
Okay.
The second column is the bits per pixel. That is how many bits of the message is able to put in one pixel. The second one is the mean square error. Here, the mean square error means that we are trying to look at the error rate between the bits when it's being inserted. So the lower the mean square error, the more better the system is. Then we have the PSNR, which is the peak signal to noise ratio. Here, the higher the peak signal to noise ratio, the more better the system is. Then the NC is actually Pearson correlation coefficient. And so here, how lesser the process is to say 1, it means that how strong the system is. And then we have the stego analysis. So I mentioned RS steg analysis. So we have the regular and then we have the singular because the image has to be divided into blocks. And so we try to look at the image when positive flip are applied and then the difference when the negative flip are applied. So the results is actually what we also have on the left side. So the embedding rate is the amount or the percentage of the message that is actually embedded. So at 5%, then we can say that, okay, just half of a bit could be put into the pixel. At 10%. So it continues like that until we get to 90%. In fact, so it means that the embedding rate, 90% of the message could therefore be embedded into the.
Okay. So how can you improve the efficiency of this algorithm?
Yes. So now the efficiency, because you see in this genetic algorithm, we use actually 27 bits. Both for the chromosome and the bits and all that. So the next one, what we are trying to do is that we would want to go for 29 bits or 31 bits because remember I said that there was a trade-off between capacity and security. And so we have tried to improve the algorithm by the use of the genetic algorithm and also the ECC. So we'll try to go for the 29 bits and then see how the algorithm will perform in terms of the real-time analysis, including the throughputs.
Okay, thank you.
Thank you.
Thank you. Thank you for your presentation. Okay, so we'll move further. We have our next presenter, Kritika, here. Can you hear me?
Yes.
Yeah, so you can start sharing your screen.
Yeah. Hi.
Hi.
Good afternoon, everyone. I'm Dr. Kritika. I'm going to share the presentation now. You can hear me, right?
Yes, I can hear you. I can see your screen as well. You can start.
Yeah, thank you. My research topic is dictionary-based PLS approach to pharmacokinetic mapping and DCE MRI using TOF model. So I'm the first author and my name is Kritika. I'm assistant professor in Department of Computer Science, Southern University, Louisiana, United States. And the other author is Nitin. He is working in Dayanand Sagar College of Engineering, Bangalore, Karnataka, India. So this is an overview of the presentation of my presentation. I'm going to explain about the DCE MRI and also about the TOF model and also about the pharmacokinetic map. Okay, and then the objectives, the related work, that is nothing but the literature survey, the results, and also the discussion on this, and then the conclusion and future work, and finally the references. So here, the DCE is dynamic contrast enhanced the magnetic resonance imaging is an approach, is a technique that uses the MRI that measures the changes in the blood flow and the tissue perfusion caused on by the injection of the contrast agents. Here, the PK maps are used, which basically provides information about the distribution and clearance of the drugs within the body. And basically, these maps can be used to understand the PK maps of drugs in different tissues, and also to optimize drug dosing and treatment planning. So here you can see, here, this is a TOF model. Here, a small, this is the small, you can see the square box here, this is called oxal. And here, the spaces between the cells is called VE, and this is a blood plasma. So if an agent, if a contrast agent is inserted on the blood plasma, the transfusion and the absorption is given here. The volume of the blood plasma is given by VP, and the spaces between the cells is VE. When the agent is contrasted, when the agent is inserted, the diffusion is called K-trans, and the absorption by here is the VP, that is the volume of the blood plasma is the VP. Here, basically, we are trying to find, we are observing this blood plasma using this model, PK model, PK maps. Here, the CE-MRI is used to calculate the PK maps, and also discloses specific about the matter in which the body, how the body reacts when the agent is inserted into the blood plasma. Okay, how we try to eliminate from the body. This mapping is actually it is done using this PK model. Here, in clinical practice, it is very important to quickly and accurately estimate the PK maps to optimize the drug dosing and treatment planning. And one approach that has been proposed to improve the speed of PK map estimation is to use the dictionary-based PLS approach. Okay, PLS full form is partial least square approach, partial least square, PLS. So here, the dictionary-based PLS approach utilizes a pre-constructed dictionary of the TOF model parameters. The parameters, as I explained here, the K-trans, the VE or VP. Now, these are the parameters which are used. These parameters are used to speed up the PK model map estimation process. Instead of fitting the TOF model to DC MRI data from the scratch, the algorithm uses a pre-constructed dictionary to identify most likely set of parameters that actually best fits that model, which actually significantly which increases the computational time required for the PK map estimation, and also the accuracy and efficiency of the model can be increased. Basically, this approach also uses PLS, which is a statistical technique that can be used to identify the most important relationship between the independent and dependent variables. Here, when I say independent and dependent variables, here the independent variables are the K-trans, the VE, and the VP. And the dependent variables are the C of E, C of T, and then the time. I'll let you know in the next slides what are these parameters. Here, the next slide is about the objectives. Here, the main, there are, here you can see the list of objectives here. Basically, we are going, I have done research on, I have done work on these objectives. The development and implementation of the conventional TOF model for the fast and robust determination of PK maps for the CE-MRI using the matrix multiplication approach or the method. And also, as I said, to improve the efficiency, accuracy of the PK map estimation. And also, actually, we have to reduce the root mean square error and decrease the computational time, and increases obviously has to increase the accuracy and the efficiency of the system, efficiency of the model. Here I have listed some of the related work. Here there have been some of the numerous
Come to the
studies and
experiment part.
hello. There have been many numerous studies and developments in the domain of DC MRI modeling for the estimation of the PK maps. And here are some of the related work. The author in the paper 1 has actually demonstrated how the standard TOF model may be merged with the frequency domain approach to speed up the curve fitting process and obtain the pharmacokinetic features. Here in the second paper, the author has explained about, has done research that describes how they effectively predict the PK maps of hidden DC MRI images at the pace of 0.34 seconds per slice. And also the few authors have worked on the NVIDIA GE Force 1080 Ti GPU, and they have efficiently generated some of the DC images at the rate of 0.34 seconds per slice. And some of and also a few the next author has demonstrated how their methods may produce accurate tracer kinetic maps. Here they have actually considered the noise realization and regression and techniques. These are some of the related work related to my field. Next, here I discussed about, in the introduction slide, I discussed about the perfusion.
Dear author, you have 2 minutes left.
Oh, okay, sorry. I'll skip some of the introduction slides. Here, basically, when the Galodian CA is injected, you can see this is the breast of the breast image. So when it is injected, after a few seconds, the clarity of this image, the tumor which is present in the breast, is clearly visible. This image clarity is enhanced by using this method. So basically, I'm proposing a method wherein the technique which is used is the PLS set technique, which is based on the TOF model, and the dictionary based some preset parameters are considered. Based on this, the parameters I'll show you at the end here. Here, this is called the ground truth, and this is the PLS, which is generated using the dictionary based parameters. When I subtract from this part to this part, okay, GT minus PLS, the ground truth is 0. This means that here what you can see after the injection, based on the preset values, you can clearly see where is the tumor is present. Based on the contrast, you can clearly identify where the tumor is present. So using some trial and error method, the dictionary is generated, dictionary is constructed, and that is nothing but the ground truth, and it is that is nothing but the PLS. The ground truth is the actual model which is subtracted, and when you subtract, okay, here you can see it is very clearly, it is very clear. That means the tumor identification is perfect with respect to the dictionary based, the trial and error, whatever we have done, those numbers, with those numbers, we can clearly identify where the tumor is present. Here, using this K-trans map, we can also find this in the true value. Using VE map, there is some disturbance here. So the predefined dictionary set is not proper. That's why there is some disturbance here. Okay, similar to this, the map is generated in the time domain as well as in the frequency domain. Here, if we use it in the time domain, if I subtract GT minus this TOF model with time domain, here I'll get 0. Right? With the frequency domain also we'll get 0. But in case of VE map, here it is 0. With respect to time domain, with respect to frequency domain, there is some disturbance. That means there is a noise. If there is a slight noise also, we are not able to identify the tumor in that particular image. And also this is the correlation analysis. It can be observed that for the PLS approach provided the best fit, the rectification of the PLS approach obtained the K-trans map in the randomly simulated data was acceptable. Okay, this means the values which we have generated, okay, it is fitting the model here with respect to K-trans and with the ground truth. And here it is not properly fitting the model. Whatever the dictionary we have generated, okay, based on the trial and error method, there is some slight variation here. It is not fitting the model exactly. Yeah, this is the correlation analysis with the K-trans and VEGT. And this is the RMS plot. Here, what we can see here is we have only the dictionary-based approach has only 32 set of data. Because when a person goes through the MRI, we can only get few points with one image, only we'll get few points. So with this, with 32 points of data, if I plot with the number of components here, 0 to 32, that is the points we have got from one image. So if I represent with respect to the root mean square error, here, if I start plotting the points here, so till here, there is no error. So when it is increasing here, the error is more. That means there is a little bit of noise. So we have to consider only these part these part, and again we have to do some trial and error method so that the errors will be less. So this is the table here, wherein I have taken two sets of data. For one set of data, these are the values. This is the time in seconds, and this is the differences here. And this is the RMS value. If it is less than 1, then the RMS value is at least tolerable. If it is more than 1, it is not tolerable. This is the meaning with respect to the TOF model in the frequency domain, the TOF model in the with respect to the PLS. And finally, the conclusion here. So when the 32 points were taken, okay, and when we used the PLS based approach, then the accuracy was around 99%. Okay, with in silico and in vivo. In silico is the simulation, and in vivo is to the living organism. If we try to inject the agent, okay, both are considered, and then the results are 99%. And then finally, these are the references.
Thank you. Thank you for your
Oh, sorry.
presentation.
Sorry,
Thank
I
you.
disconnected.
No problem.
Yeah.
Thank you. Thank you for your presentation. Ma'am, any questions?
No questions.
Okay, right. Thank you, Kritika. Thank you for your presentation. We'll
Yeah.
move forward now.
Yeah, thank you.
Thank you. So we have our next presenter, Soumya Kanti Dhara. Are you here? Soumya? Okay. Do we have Ruchi here?
Yes, yes.
Ruchi, you're here,
Yeah.
right?
Yeah.
Okay, so you are ready with the presentation?
Yeah.
Okay, so you can start sharing your screen.
Yeah, just a minute. Okay, good afternoon, everyone. I'm Ruchi Chakravar. Today, I'll be guiding you through our work on OpenStreetMap-based indoor positioning system. To begin with, let me start about a short introduction of what OpenStreetMap, or alternatively or famously known as OSM is. OSM is basically, in layman's term, what is Google Maps, but the advantage of OSM is that it is free and it is editable. Why it was developed was basically when we embed Google Maps into our APIs, we have to pay a certain amount to Google. But with OpenStreetMap, since it is free and open source, we do not have to do so. It is largely built by volunteers, developers from scratch. The initial focus of OpenStreetMap was to just geopin streets and say landmarks, but it has moved far beyond those entities. Now, why we need indoor positioning and why GPS is not suitable for indoor positioning. So GPS is not suitable for indoor positioning because it relies on direct line of sight connection with at least 4 satellites to determine the location accurately. So when we are in indoor, it is not possible. And now you may ask why indoor positioning, especially in a country like India where the GPS is still not very accurate. So as we know, India is a very fastly developing country with increase in high-rise buildings all over the country. And as someone who every one of us mostly goes to these buildings, may it be trade centers or hospitals or colleges or offices whatsoever, there is a certain amount of difficulty in finding a particular office or location, etc. So it would be easier if we had an application on our phone that would lead us to those particular locations, especially in places like hospitals or examination centers or colleges, which would save the time and it would make it easier and efficient. So to address this need, with existing technology that is already present in most buildings, the best approach, which is not really very accurate, but the best approach is use of Wi-Fi signals. With the increase of technology, there is a Wi-Fi router in every single building, every single household. So we can use those said Wi-Fi signal to analyze the nearest position, and machine learning algorithms will help us pinpointing the location within the building with reasonable accuracy. Since we use Wi-Fi, the accuracy is not that much as of now. So like I said, the motivation for us was since we have a huge college infrastructure or campus, and we spent 2 years of our college at home because of the pandemic. So even until our last year, we had a little confusion as to what classes or laboratories, and with so many buildings that continue to rise, indoor positioning is a huge market that is not basically necessarily tapped in. So we studied a bunch of research papers, already established systems, and these are 2 existing systems that we researched or basically studied for our application. One was OSM and one is OpenStreetMap. OSM and is basically an offline map service. It displays like choice places only. So if I have to put it simply, it is basically a paper map, but on your phone where you can zoom, etc. And it will also provide you directions when you're connected with the internet. Or OpenStreetMap, or the already existing OpenStreetMap database, was one we studied. So now the problem statement and what qualities of OpenStreetMap that we included in our application. So the problem statement is basically that navigation and positioning in indoor buildings is very necessary in this day. Alternate systems for GPS, etc., are being researched. So wireless technologies like Bluetooth, Wi-Fi, and infrared are very popular. And what qualities of OpenStreetMap that we have included in our application is, one, it is open source, and the second, it is editable by the user. Like when you go, you can edit it to your needs and liking. So the objectives of our application or the work we did is, first was to calibrate the coordinates of the current position of the user with the help of radio signal strength. So what it means is, wherever you are in that building, you first need to know, the application will first of all take the radio signal strength from the Wi-Fi of that current position and calibrate it. And the next objective was to find the nearest location from the user's current position. So for this, we use RSS, or radio signal strength of the Wi-Fi, and we find the nearest location from the user using the k-nearest neighbor algorithm. There are two phases. The proposed methodology has two phases for determining the user's location: calibration phase and the positioning phase. In calibration phase, several positions inside the building are chosen, and the RSS values of Wi-Fi are noted and recorded and stored in a database. They all are stored in a tuple. And then the second is the positioning phase. The RSS values that are recorded now, after calibrating all the locations in the building, the second phase, that is the position phase, is now when a user is in the building and the values are recorded from on an unknown location, and then the k-nearest algorithm is applied to find out which location is nearest to the current location of the user. After using our application on different devices and in various buildings, the calibration phase does not really need an accuracy rate, since it is just inputting location. Whereas the positioning phase, after a few rounds of testing, showed around 70 to 75% accuracy. This application can't really be used in small homes because since the accuracy is not much and the area is very small, it is more suitable for huge buildings such as colleges or campuses, etc. So to conclude in future, for conclusion and future scope, so OpenStreetMap, like I said, is an open source geographic database. Wi-Fi positioning systems are an effective solution for indoor location tracking due to their scalability and ease of implementation and availability. There is research still being conducted for creating alternatives for GPS replacement in enclosed spaces. Infrared and Wi-Fi and Bluetooth are the majorly used technologies. This technology can be used in various buildings, including shopping malls and hospitals, universities, etc., without incurring additional infrastructure costs. And more on, we can also implement, after going forward, we can implement navigation, we can implement hotspots, etc., in a particular building. We can also implement radio maps, so that whenever a user installs the application and connects to the Wi-Fi in the building, they do not have to go through the process of calibrating every single position. A radio map will be automatically loaded on their device. And furthermore, with the help of
how many research papers you have studied for?
Ma'am, around 6, around 10.
But you have not mentioned.
Yeah, ma'am, just a minute. Ma'am, so in the presentation, there are only 3 mentioned that we found more suitable for the content.
Okay. Thank you. Thank you.
Thank you.
Thank you, Ruchi. Thank you for your presentation.
Thank you so much for having me.
Thank you. So we have our next presenter, Soumya. Kanti, can you hear me now? Soumya. So what's the problem? Please fix your problem and come back soon, sir. I can see your screen, but I cannot hear you. Do we have Vismaya?
Yeah, hello. Yes, I'm here.
Yeah, Vismaya is here, right? You can start with your presentation, ma'am.
Yeah.
Please share your screen.
Sorry, I'm not able to share the screen since it is.
Now you can just try again.
Okay, is it visible?
Yes. It's visible now.
Okay, yeah. So hello everyone. Good afternoon, everyone. My name is Vismaya AV. The topic of the presentation is prediction of higher education students programming skill using IRT. IRT is basically item response theory. So these are the contents which I'll be going to explain. So what IRT or item response theory is, it is a statistical framework used to model how individual responds to items in an assessment. So the main problem definition of the project is it mainly predicts the student's programming skill based on the item response theory. So coming to the objectives, the main objective of the project is to assess the student's skill based on the responses which we receive through the Google Forms and to provide the necessary feedbacks to the individuals. And the last objective is to improve the accuracy of the evaluation process by making it a completely computerized system. When it comes to methodology, first we pre-process the data, like we arrange the data from highest to lowest form. Then we take the 27% of the data from the top and from the bottom, and we calculate the top 27% total score as PT, that is the marks scored by the higher group, and PB will be the marks scored by the lower group, and the capital N represents the total number of learners or the total number of responses which we received through the forms, and the small n is the number of learners in each group, that is the 27%. So first we find out what is difficulty index. Difficulty index is nothing but it is the measure of the proportion of learners who answered the item correctly. So to find out what is the difficulty amount of each question, we use this particular formula. And when coming to the discrimination index, it is the measure of how well an item is able to distinguish between learner or who are knowledgeable and who are not knowledgeable. So the discrimination index is used, is calculated using the formula PT minus PB by N. After finding out the difficulty index and discrimination index, next what we do is we find the probability of a student answering one question. To find the probability, we use the formula P of theta is equal to Ci plus 1 minus Ci by 1 plus e to the power minus ai whole to the power theta minus bi, where p is the probability, c is the pseudo guessing parameter. A pseudo guessing parameter is nothing but what is the percent of a student guessing the question. Like we'll provide only the MCQ type of questions in the Google form. So what is the probability of he or she guessing the question or guessing the answer? That is the pseudo guessing parameter, and A will be the discrimination index and B will be the difficulty index, which is calculated from the above formulas. Next, what we do is we'll find out the log likelihood function for the given responses. When we found the log likelihood function, from that above formula, we'll derive it again, or we'll differentiate again. So the first derivative or the differentiated equation will be called as the Bayesian equation, For that Bayesian equation, we apply the Newton-Raphson method, where we calculate the theta. Theta is the ability. So finding out theta is the whole process in the project. So this is the sample data set what we have collected. Here how I have mentioned how I have calculated the difficulty index and the discrimination index. Next one, to the system.
Because it is not visible. The data set is not visible.
Okay.
Click on full screen.
Is it visible now?
No, it is not visible.
Okay.
Make it full screen.
Is it visible now?
Okay. Okay.
Okay. So when coming to the system architecture, this is the student module. In this project, we have mainly used two modules, that is a student module and a teacher module. So in the student module, first the students logs into the interface, which is connected to the student database. Then the student will choose like whether his or evaluation should be done with the help of one parameter logic or two or three. So basically what one parameter logic is, this model mainly assumes that the probability of the correct response is mainly dependent on difficulty of the item. And when coming to the two parameter logic, this model includes the difficulty as well as the ability factors, which affects the probability. When coming to the three parameter logic, it considers three parameters. That is, it also includes the guessing parameter. So widely nowadays, three parameter logics are used. Just for the information purpose, I have added one parameter and two parameters also. So next the evaluation. Evaluation will be done with the help of the testing agent, which is connected to the item database and the test database. Next, the assessment will be done by log likelihood, which is wrapped by Newton-Raphson method. And logistic regression will be used for the predicting accuracy. And next, the feedbacks and the results will be displayed. So this is the teacher module. So the teacher logs into the interface, which is connected to the teacher database. The interface which the teacher logs in will be known as the activity agent, where the teacher can update the database or modify the database. These are the results. This will be the login page. So when the student logs in, the next page which appears will be the one parameter logic, two parameter, and the three parameter. And live testing option will also be provided. So here the student will upload all the details of the items or the exams. So this will be the score which the student will receive. This is actually scaled to 800. It can be scaled to any number. Since the standard number is 800, so I have scaled it to 800. So 794 will be the score of the student, and the feedback will be provided, and also the predicting accuracy will also be displayed. And this is the interface of the teacher's module. The same login page will be displayed. This will be the page after the teacher logs in. So he can update the items or update the test, where he can add questions. Sorry. Hello.
Yes, please continue.
Yeah, this will be
Faster, please.
Sorry, I'm not audible.
Faster, please. You have just already crossed the time.
Okay. Yeah, this will be the question updating page. These are the reference.
Okay. Okay. Ma'am, any questions?
Yeah, can you explain the system architecture? And is there any comparison? Okay, this is the results.
This one, student module.
Yeah, system architecture.
Yeah. So the first, the user logs in, which is be connected to the student database. Then the evaluation will be like the student can choose what kind of evaluation should be done. Is it one logic or two logic? I mean, two parameter logic or three parameter logic. The accuracy will be more provided in three parameter logic. So that will be chosen by the student. and the testing agent. Testing agent is the evaluation process which where the item database and the test database will be connected. And the assessment will be done based on the log likelihood and the Bayesian equations, which is wrapped by the Newton-Raphson method. And the logistic regression is the predicting accuracy, where the prediction accuracy will be displayed. And based on the theta values, the feedbacks will be provided.
And where you have
Okay.
taken this data set?
A data set, like I have created a Google form and I have provided to my team, I mean, college students. From there, I have taken.
Okay.
Okay, thank you for your presentation, Ms. Maya.
Thank you.
Thank you. Soumya, can you hear me now?
Am I audible to you, ma'am?
Yeah, you're audible now.
May I get your permission to start my presentation?
Yes, please share your screen.
Is it visible?
Yeah, it's visible. You can start.
So I'm going to the slide some more. So good afternoon, all of you in this session. So I'm going to present measuring the behavioral intention towards the implementation of super artificial intelligence in healthcare sector to steer the advances in ICT. It is an empirical analysis with structure equation model. Now we start the introduction that growing population in the world have been posing a growing challenge in the healthcare services. And ICT is playing a significant role in enhancing the capacity of healthcare sector. So technologies that are gearing up the ICT industry are machine learning, natural language processing.
Please come to
Deep
the
lear-
objectives. Objectives. Come to the objectives.
Okay, so this is the theoretical background of the study. We are taking the technology acceptance model and theory of planned behavior, say a conglomeration model. So this is the objective of the study. So to examine the effect of the constructs, perceived usefulness, perceived ease of use, attitude towards use, and it's how it influences the behavioral intention towards use. This study also examines the subjective norms on behavioral intentions towards use and the effect of moderating construct, that is perceived behavioral control, to gauge the influence of attitude towards use on behavioral intention of use. Now, from the literature, we have surveyed nearly 12 literatures, and from that literature, we have developed the hypothesis that is H1, PU, that is here, it has a positive significance, perceived usefulness, to influence the attitude towards use. The second hypothesis is perceived ease of use has a positive significant influence on the attitude towards use. Hypothesis 3, attitude towards use has a positive significant influence on behavioral intention to use. And H4, that is this one, subjective norms, it has a positive significant influence on BIU, that is business, that behavioral intention to use. We have used this PBC, that is perceived ease of use, this perceived behavioral control. It is acting as a moderating variable, and here it is altering the degree of positive influence on the relationship between ATU and BIU. Now, the research methodology, it is a descriptive research methodology with cross-sectional research design. and it has been used for collecting and analyzing the data. So a close-ended structured questionnaire was distributed among 300 employees of healthcare sector having the knowledge on artificial superintelligence, among which only 285 complete responses were received. We have used convenient sampling for the study, and almost the study was conducted for a period of 3 years. Now, 5 study measures, say the factors and associated measurement items, have been considered. Total of 17 variables which were identified in this case. Here, in the first stage phase, and content validity of the questionnaire were executed and the reliability was checked. We used the SPSS 28 and AMOS 28 to conduct the data analysis. The conformity factor analysis was performed to test the concerned measurement model. The ACM, that is structural equation modeling, it was used to check the effect of the independent variables on dependent variables. And finally, the moderation analysis was conducted through SPSS process macros. Now, in the result, Harman's one-factor test was used to examine the common method bias, where the maximum variance described by the single factor was 29.16%, which is less than 50%, representing that the common method bias was not a potential threat. Goodness of fits were checked and found suitable, which indicated the evidence of construct validity. It was observed that all factor loadings are more than 0.7, and the total variation explained was 84.66%. So also 5 factors from 17 variables were extracted. So this is the final model where we have represented the path analysis. That means the path it is a path diagram where we have represented through path analysis. It reflects the hypothesis assessment is represented in the form of beta values and p values. To test the hypothesis, we have calculated the standard regression estimates, that is referred as beta values. And here the result proposes the positive significant influence of all the factors on behavioral intention towards use, with the exception of subjective norms, which have a negative influence. So the regression estimate, beta is equal to plus 0.513, with p-value less than 0.01, it depicts that moderation effect of the perceived behavioral control stated in the research is also justified. Now we are coming into the conclusion and limitation as well as scope of further research. Since super AI has been proposed to behave smarter than human brains in every field, say scientific research, general insight, and social skill sets, its use will enhance the degree of relationship between the constructs of the model developed for healthcare information system. And as per the principle of super AI, the relationship may be self-modified to make the model more optimized. As super artificial intelligence is still under development phase in ICT industry, there is limited availability of literature in this application. Moreover, the respondents who have been selected for the survey, they were not the users of super AI to provide sufficient evidence. So further researches may be conducted to exemplify the relationships between the construct used for TAM, that is a technology acceptance model, and theory of planned behavior for future evidences that should be collected through deployment of super AI. Thank you.
Nice presentation.
Thank you for your presentation. Any questions, ma'am?
No, it was a good presentation.
Okay. Okay. The presentation, Soumya.
Yes, any questions? Any questions?
If any participants have any questions, they can drop the message in the public chat forum. Okay, thank you. So we have our next presenter.
Thank you, ma'am.
Thank you. Vaibhav Kumar, are you here?
Hello, am I audible?
Not that clearly. Please increase your volume.
Just a sec, please. Hello, am I audible now?
Yeah.
Okay. Thanks, Deepika. And good afternoon,
Just a
ma'am, and
minute.
everyone present.
Just a minute. You are logged in by Vaibhav and Anshuk Nawal,
Anush,
right?
let me
Anush.
finish this.
That
Yeah,
is
I am
you?
Anush
Is
Naval.
that you?
Yeah,
Okay.
I will be
So-
presenting the today's presentation on behalf of Dr. Vaibhav.
Okay, you're the co-author?
No, I am the primary author of the paper. And sorry.
All right. Okay.
Yeah.
Thank you. Continue, please, sir.
Is my screen visible to all of you or not?
Just a minute. Yes, it's visible. You can start.
Yeah. So, good afternoon, everyone. I'm Anush Raval. I'm the primary author of this paper, Quantifying Vertical Farming Potential Using the Digital Twins. So, as Soumya and Ruchi already said, that India is a fast-growing economy, and there is an increase in urbanization as we speak. So, regarding that, there is a shortage of land in the urban areas, and due to that, there is food shortage and the availability of green land which can be processed for agriculture, and also reducing the green spaces, which is causing urban heat effects and other effects that are causing less risk to sustainability in the urban environments. So our focus of this paper was getting vertical farming into the skyscrapers in the cities. So we want to give emphasis on the vertical farming, which is a method of doing crop farming on the vertical facades, which are balconies or the uh, windows of the tall buildings. And we also want to increase the area in green area in the urban settings. So by vertical farming, we are basically targeting 4 of the main SDGs goal: the zero hunger, good health, and affordable and clean energy with the sustainability city planning in our mind. So these are some of the papers which we reviewed. These are the papers which give us the qualitative analysis that there are many sites which are present in the building, the residential building with or the commercial buildings which we have in the urban settings. And using that as a reference, many projects are structured, like the Kia T2 terminal project and the line project in the Dubai. So to process this, we made a problem statement, like to develop vertical farming parameters and simulate if it is possible in our settings where we live, and also to validate the simulated data with the real data, which will provide us if we can trust it or not, and also give a quantitative measure to any decision planner if the vertical farming is possible in their locality or not. So for that, our approach was to create a 3D model. And by 3D model, we are using the level of detail 2 models, which are just block 3Ds and of the buildings. We acquired the OSM from free sites from the net, and we generated buildings over that particular building footprints, and we plugged it in with the meteorological data, which is provided by the EPW files, which are energy plus weather files, and are recorded at the nearest weather stations. So we combined them to get a digital twin, and we also collected IoT data so that we can correlate if the results are true enough or not for our studies. And then we produced a solar radiation study because plant requires solar heat, solar energy to be there. And also by solar radiation study, we then quantified the potential area which will be there in the locality, and also provide a neighborhood sensitivity analysis of that particular area. So our area of interest was ICER Bhopal, which is Indian Institute of Science Education Bhopal. And this area, we generated the 3D model using the OpenStreetMaps. And this is one of the GIF which is showing that how contour makes the topography, and over that we place the building and generated the 3D model of our desired location. The IoT device mainly captures the temperature, humidity, and light intensity at the facade level where we are placing. We have placed 4 sensors at different level to cross verify if there is any height variation in that particular region, or there is something other which we can derive from it. So this is one of the sun irradiance simulation. Here the sun moves from east to west from morning to evening. We took the time, and the left image is showing a object where the light is going falling on, and it's capturing the simulated data is captured by the simulation. So these are the results from our IoT device. So first we try to cross verify if our intuitions are right. Like if the building is facing in the west side, the west direction, like the site one, it will be receiving some of the sunlight in the afternoon session as compared to the morning sessions. And similarly, a site facing in the east will be getting more heat in the morning time, which is our site 3. And with that, we also correlated the temperature and humidity. As the temperature increases and the humidity drops at the site. So about the correlation of our stuff is the solar irradiance curve, which we plot from the data, which is simulated data, and the IoT data is shown in the figure. It have a correlation of 0.99, which shows that the data is more or less same as we have approached it. We tallied this data over the period of 7 days and measure it from morning 7 to evening 6. So we can, the get through is we can get the simulated data can be trusted. So these are the table which are acquired by the literature reviews. This shows how much energy or how much solar radiation is required by each plant in a different category to get it growing. And based on that, we developed this simulation over the particular time of crop growth, and get this level of favorability, which is nothing but the possibility the crop can grow on that particular area, on that particular face of the building. So this is the example of one of the face of the building, which is showing that is tomato. A tomato can be grown or not grown. So as the color is mostly red, it can be grown at this side of the building. While if we go for high uh, high and solar energy needing plant like cannabis or something, we can plant it, and it can be grown at the B side. So one of the situation was the thing was not totally accurate. So we thought what can be the factors, and one of the factor was the neighborhood which is affecting that particular area or region. So as we can see, this main building which we are having is surrounded by few buildings and also trees. So this gives some of the this blocks some of the light and give the side of the face some of the possibility of favorability to that particular side to grow that certain type of crop. So we can see the difference between each of the vegetations which we have taken into account. So this is the result from that particular analysis, like what contents without the content and with the content. Here, content means the neighborhood effects on the particular building. So the building was divided into
Dear
11,000
presenter, 2
grids.
minutes left.
Yeah, sure. Thank you. So we have 11,000 grid in our study, which we divide the building into. And each grid get a possibility how if it's favorable or not. Above 50% probability, we consider that the crop can grow on that particular place. And we get this table where each species of plant is corresponded to how many potential grids can we get in the area of potential vertical farming. And last column will be the percentage change considering the effect of that particular neighborhood around that particular building. So similar various vegetables potential can also be mapped using the same structure. And for conclusion, the vertical facades farming can be used to increase the green cover in our urban settings, which can also minimize the urban heat effect. And we have tried to implement it on the city scale. And neighborhood can be structured as to increase the potential for the area so that more crops can be grown at that particular level. And advanced scope will be like we get more data of more species to accurately justify which species can grow there. And also we want more parameters, like we considered only humidity, temperature, and solar irradiance. So more parameters like wind speed and all can be integrated in this to make it more real and give more precise results. And also crop rotation can be introduced in this particular section. With this, these are the references, and thank you for the time. I can take questions.
Any questions, ma'am?
Anush, can you explain the approach slide again?
Approach slide. Okay. This one, right? So what we do is we select a site.
The IoT data. Yeah.
We select a site like it's an interested site, and we get the LOD2 model, which is very available cheaply. Like you need to get an OSM and get it, get the building footprint and make the LOD2 of that particular building. Then we have meteorological data, which is acquired from the nearest weather station, which is available online. We can search it, and we just couple it to form a digital twin, a representation of physical world in the digital setting. And then collected data was for the correlation, if we can trust that particular digital twin or not. If our what we can say accuracy is less than 80%, we think we can consider it as a true value. But we found that the data is more or less similar, as we have seen in the graph. The correlation is 0.99. So we think the digital twin or the simulations can be trusted. So after digital twin is ready to go, we just plotted the solar radiation study. We did the solar radiation study using the Grasshopper plugin, which is a feature in the Rhinoceros software, and get the quantification of the potential area for that particular building. And if we also do up in the neighborhood, like the buildings, then we can get the neighborhood sensitivity of that particular area.
Okay, thank you. Thank you.
Thank you, ma'am.
Thank you. Thank you so much. Okay, so we have our next presenter here.
Yes, hello.
Yeah.
I'm here. I can share my screen.
All right, Andrea, you can present your paper. Can you hear
Thank
me?
you. Yes.
Yeah, you can start sharing your screen.
Is it visible?
Yeah.
So good afternoon, everyone. Today, I'm excited to present our paper on the resourcing of small indigenous languages in low resource environments. The paper has 3 authors, myself, Andrea Panayotou, Mr. Francis Sadido, and Dr. Alan Bon. Therefore, I'm presenting on behalf of the team. Today's presentation comprises 5 key sections. First, about the project, which provides an overview of the main project called the Bali. Next, we'll explore the importance of the project. Then in the methodology approach, we will discuss our user-centered design process. Fourth, in the crowdsourcing app section, we introduce the app with the main features of it. And lastly, key findings, will summarize crucial insights and outcomes. This paper is under an existing project called Dimbali, which is a field-based case study in Ghana. This research is carried out with the objective to develop ASR-based voice service to provide weather and rainfall information to rural communities in their own native language. Developing a data collection app to generate a speech corpus is the first activity in the research project. The data collection tool targets online communities that speak the chosen language and that are already involved in the community center work. Data collection starts the selected Nyakbala and Digboli communities in the Tolon districts and may be expanded in other regions too. Let's see some challenges faced by small indigenous languages in low resource environments. As we mentioned, these languages are invaluable repositories of cultural heritage and traditional knowledge. However, there are prevalences in regions with low literacy rates and limited access to digital services pose significant obstacles to their preservation and utilization. Colonial history has further compounded the situation as many countries in the global south had the colonizer language imposed at the lingua franca. This adoption of the foreign language pushed away many indigenous languages, leading some to disappear or face the threat of extinction. In our research, we have observed a growing interest in conserving indigenous languages and culture through digitalization. However, the cost of the voice services are generally high, and digital data, whether text or audio, from these languages are rarely available. Also, by providing voice services to these languages, we aim to bridge the gap that exists and connected communities to the digital era. Let's take a closer look at the methodology we follow to address the challenges of our use case. Our approach is rooted in user-centered design, ensuring that the needs and preferences of the indigenous language speakers are at the forefront of our development process. The methodology consists of 6 key steps, each playing a crucial role. Firstly, we transfer ideas into a rough conceptual design during the sketching phase, visualizing the user interface and data collection system flow. Then interactive prototypes were created, allowing us to simulate the user experience and gather valuable feedback from indigenous language speakers. Step 4 was extensive user testing sessions to involve observing interactions and collecting feedback, providing the insights of the user needs, preferences, and challenges. In the iteration stage, involve analyzing collected data, refine the system, and incorporate user feedback to address challenges and improve the design. And of course, at the end, we repeat the steps of the prototyping until we were sure that all the needs were covered. Based on the use case diagram that you can see on your right part of the slide, we can identify key functionalities that the final system should perform for 2 potential users, the Dagbani speaker and the developer. Both users have access to the Firebase cloud service that we are using for our system to save or see the recordings depending on their privileges. Dagbani speaker can easily participate by using a crowdsourcing app on their smartphones. By recording and submitting Dagbani words, they actively support the project development and presenting efforts. Also, the necessary checks and appropriate pop-ups appear in order to help the user understand the system. Then developer main use case is to monitor contributions and app performance. They can then view uploaded recordings, collect data and recording statistics, export data for reports, and other things. After prototyping, we got some valuable feedback, and it's important to balance user requirements relevance with ease of implementation and cost, which is really crucial. You can see the diagram on the right part of the slide. So in order to achieve this, we employed the MOSCO method, mapping user value against implementation cost. For example, some of the selected options are changing return state after the recording in order to enhance user friendliness, or reduce pop-ups for a smoother experience for the user. And some of the not selected ones are recording of sentences or create the app as multi-language in Dagbani. Through careful consideration and balancing the user needs and time available, of course, we ensure the app's initial development aligns with immediately objectives and long-term goals. Now let's see some key features of the data collection app designed to resource the Dagbani language and facilitate the generation of speech corpus. First, the app allows users to record audio and data of the Dagbani language, either a lot of words from the same category, either separate words. Also, real-time feedback was available to ensure that users can review and re-record if any unclear or noisy audio results in high-quality speech corpus. Moreover, our design prioritizes user experience and ease of use. In addition to secure and centralize the collected data, the app integrates cloud-based storage, audio files that are uploaded to the cloud, the Firebase that I told before, ensuring data preservation and accessibility for analysis and future use. And lastly, offline support, recognizing that internet connectivity might be intermediate in remote areas. The app supports the offline recording. User can continue recording even without an internet connection, and the data will be uploaded when the connection is restored again. And as we conclude this presentation, let's see some key findings. First, our study led to two significant outcomes. We successfully developed a data collection app that caters specifically to the needs of the Dagbani community. Additionally, we established a general method for effectively resourcing other indigenous languages. And let's see some also key findings that emerged our research. Firstly, to ensure the cultural sensitivity and accuracy, it is crucial to collaborate closely with native speakers of the targeted language during the resourcing process in order to understand their needs. Secondly, at the start of any language resourcing project, conducting throughout context and stakeholder analysis is essential for successful implementation. In addition, a very important aspect was the limitation of the communication gap with field visit and test session, and specifically real-life demo, rapid prototyping, allow us to elicit user requirements more effectively, leading us to a user-centered app design. In order to strike the balance between the user needs and the development efforts that we got from the feedback, we utilize the MOSCO method for prioritizing the requirements. And lastly, designing for low resource environments requires a keen understanding of contextual conditions and limitations. In conclusion, our study underscores the importance of user-centered and context-aware approach in preserving and resourcing indigenous languages. Thank you all for being a part of our presentation today. We truly appreciate your time and attention. A special word of gratitude to the Internet Society for the invaluable research grant making the Dipali project in Northern Gala possible. And also we'd like to also thank ICT4SD conference in Goa for giving the opportunity to present today. If you have any questions or further information, please feel free.
Any questions, ma'am? Okay. Thank you, Andrea. Thank you for your presentation. It was a very good presentation.
Thank you.
So we have our next presenter, Abhishek Rathi here. Can you hear me?
Hello, Deepika. Yeah. Am I
Hello,
audible?
yeah. Yes, you're audible. You can start sharing your screen.
Okay, just a second. Is it visible?
Yeah. You can start.
Good afternoon, everyone. And good afternoon, ma'am. My name is Abhishek Rathi. I am recent graduate from DTU. Today I will be presenting the work which we have done, which is taxonomy of structure-based routing protocols for IoT. This will be the presentation outline for the today's presentation. Let's start with the first content, problem statement. So as we have seen, in daily life, the utilization of IoT has risen, like from smartwatches, computers, smartphones, everywhere. Also, there are many challenges which are coming towards us, which are availability of reliability and data security, etc., etc. To address these challenges and achieve the efficiency in the communication, various routing protocols are employed. These protocols define the data packets are forwarded from source to the destination. Uh, we have studied the different routing protocols in details on the various parameters, the advantages and the disadvantages and the difference between them. And we have identified different routing issues and challenges which need to be addressed in the coming future scope. Next thing is methodology or data set. So initially around 300 relevant papers were searched from various digital databases uh, such as Google Scholar, ACM, IEEE, Springer, Scopus
Come to the
elsewhere.
objective part.
Yes,
Objectives.
ma'am. Just a second. So basically, what we have done is there are three types of routing protocols. Mainly, there are three types of routing protocols, which are network layer routing protocol, network organization routing protocols, and part discoveries. So these three have different their roles in the routing protocols world. So what we have done is that we have analyzed all the different routing protocols which are under these protocol layers, and then we have distinguished the various parameters between them and given a very structural and very structural taxonomy on them so that everyone can do their researches. So let me start with the first. So flat based routing protocol is also a horizontal routing. This approach plays a crucial role in networks with a horizontal or flat topology. In flat based routing protocol, all nodes within the network are treated as equals, possessing the same capabilities. This eliminates the need for complex network or traffic coordination, simplifying the entire infrastructure significantly. One of the key applications of flat-based routing protocol is its use in IoT networks, offering practical solutions to overcome various independent challenges. This not only leads to the simplicity, but also enhances the overall dependability of the network. Moreover, flat-based routing protocol ensures reliable communication and seamless data transfer between the interconnected devices, which is crucial in IoT. With a reliable and efficient solution to address the challenges faced in the IoT networks, such as simplicity, minimal operational complexity, and dependability, it paves the way for smoother and more effective operation. So, if in conclusion, the flat-based routing protocol is a fundamental approach in the modern networking, particularly beneficial in IoT networks. Its fair and practical natures empowers all the nodes equally and offers a dependable and efficient solution to the various challenges. Uh, Next, these are the four types of flat-based routing protocols: SPIN, DD, RR, and MCFA. More about this is there in the research paper draft. Uh, we have distinguished more the comparative analysis, which will be showing in the next slides. Next, we have hierarchical based routing protocols. This approach is widely used in the networks with a hierarchical or layered topology. It plays a pivotal role in the ensuring efficient routing and management. In hierarchical routing protocol, the network is divided in multiple hierarchical layers such as clusters or domains. These divisions allow for better organization with higher level of nodes having more control and decision making capabilities. One of the key advantages of this protocol is its ability to enhance scalability, particularly in large scale networks like IoT. By dividing the network into smaller domains, routing decisions can be made localized, significantly reducing the overhead associated with the routing information. This localization minimizes the impact on the entire network, leading to more efficient and optimized resource utilization. In conclusion, if the hierarchical routing protocol is more powerful and efficient approach to manage the complex network. By dividing the network into hierarchical levels and organizing nodes into the localized domains, it optimizes the resource utilizations. There are 6 type of hierarchical based protocols: VGR, self-organization protocols, Leech, Teen, Aptine, and Pegasus. The third type will be location-based routing protocols. This protocol is gaining prominence in the networks where the physical location of the devices plays a crucial role. The location-based routing protocol utilizes the geographical coordinates or the addresses of the devices to identify the most appropriate path for the data transmission. Unlike traditional routing protocols, nodes in this protocol make routing decisions based on the physical distance to the destination. By leveraging location information, the protocol can dynamically adapt to changes its network topology, making it highly suitable for the dynamic environments. Data packets are forwarded based on the physical location of the devices, allowing for optimized and efficient data transmission paths. One of the key benefits of the location-based routing protocol is the reduction in routing overhead. By using location information, the need for network-wide flooding or global routing updates is minimized. This results in lower control traffic and improved scalability, making it deal for the large and complex networks. The location-based routing protocol is a game changer in the modern networking by considering the physical location of the devices to determine data transmission paths. It offers improved efficiency, energy savings, and adaptability in dynamic environments. Embracing location-based routing protocols can lead us to more robust.
Next slide, next slide.
Just a second. So these are the types of
Is there any
location-based routing
comparison table you have done?
Yeah, ma'am. So
Yeah.
these are this is one of the comparison tables from the draft which we have done. These are the comparisons between these all routing protocols on. So we have compared them from one another on the basis of the control overhead, based on query adaptability strength, based on scalability, and support multiple routing. This is for location structure routing protocols. There are for flat also and hierarchical also. Next is the findings and summary. So this is the what we can summarize is like flat routing protocols are simple.
How many research papers you have studied for this?
Ma'am, in general, we have studied around 14 to 15 research papers.
Have
Some
you
of which,
mentioned? Because
yeah,
you have
yeah,
not
ma'am.
mentioned where you have mentioned.
I have mentioned the references at last. Also, these all are mentioned in the paper draft also. Some of these research papers are also the survey papers of many other research papers.
There is no
So-
latest research paper you have studied, right?
No, ma'am, there is no,
Right.
also there is
Last
not
paper
any
is
other.
of 2016.
Yes, ma'am.
Just check it out because there is a latest research done by SRM University professor.
Okay, ma'am. I might have missed that. But yeah, what we have done is that we have simply analyzed and differentiated the different routing protocols so that it can be easier for the uh, other guiders or students to analyze the different routing protocols perfectly.
One suggestion
Uh,
I wanted to give for the presentation is there is so much of content you have written in your PPT. There is no need. Just make a table of it and then you can mention. No need of such mentions of the content. There's
okay,
so much
ma'am.
of content you have mentioned.
Thank you so much, ma'am, for your feedback.
And please refer the latest research papers of 22-23, right? Because the last paper is studied of 2016 of ICT4SD.
Okay, ma'am, I will refer them.
Thank you. Thank you for your presentation,
Thank you
Abhishek.
so much, ma'am.
So we have our next presentation by Lakshmi Kale. Are you here?
I am representing in instead of Riddhi Dage. The topic is implementation of recommendation system services model using Amazon e-commerce dataset. I am sharing my screen. Why it is not visible? I am not sure.
It's visible. You can start with your slides.
Okay, ma'am. Thank you so much.
So focus on the main topics, yeah? Focus on the main topics and don't just keep reading. Faster, please.
This is implementation of recommendation systems service using Amazon e-commerce dataset. The main purpose of this project is to provide small scale businesses and startups with its basic ERP-like structure where the content is, the model is structured to them. Instead of implementing from scratch the recommendation system, the small scale business entrepreneurs can get the systems as it is ready. The purpose is to build hybrid recommendation model to deploy as a service. This could be used by online any small scale business firm by simple API calls. The objective of this system is to provide recommendations based on the recorded information or on the user's preference. It is to provide open source recommendation systems to all small businesses. These are the literature surveys we have done. First paper we have referred is for comparison of all filtering techniques. And then we found that random forest filtering technique was the having good accuracy. Then we have searched for collaborative filtering techniques, and then we found that the collaborative filtering techniques also working for good for with hybrid method machine learning framework. This is our system architecture where we are starting with a client, and then registration. After registration on the portal, our recommendation service will work at the back end. It will take input from the content from the users depending on their choice and recommendation. Depending on the previous history of their choices, we will train the model on content-based filtering and collaborative filtering to get the users again a actual perfect recommendation. We have actually done this with a users data set. We have there two data sets we have used. First is ratings data set and the product data set. In the rating data set, we have used 7,31,000 records for and collaborative filtering methods are used. The recommendation rating from 1 to 5 scales is used, and timestamp is the time where the recording is actually done, the rating is actually done. Product database consists of 55,000 records, which are used in training the model. 70-30% training and testing model is used. This is evaluation experimentation method where hit ratio at the rate 25 we have calculated. To calculate hit ratio, first we have created pair for the testing. Then list of 99 items is generated. These 99 items will predict the likelihood of the user's interaction, and top 25 items will be considered for this. And then these items will be again tested for the list we have obtained as a top 25 list from other users' recommendation. And then if the hit happens, then it is considered as hit ratio 25, and the all hit ratio 25 is calculated as the average hit. The results we have got like this. The graph we have plotted for the results. First of all, we tried with the EPOS, 20 EPOS and 32 batch size. Then we increased the batch size of 64, and we got the results like this. The orange line in this is showing us the validation loss, and the data blue line considers the training loss. So we are getting downside training loss with batch size 64 we are increasing. But we approached to batch size of 512, and then we concluded that the hit ratio is most, that is 64% when batch size was considered as 512. And this is our conclusion, that we have utilized a hybrid recommendation model approach. They are combining collaborative and content-based filtering techniques to provide accurate and diverse recommendation. As we are recommending it for small businesses who just going to use their API, our API to recommend to the customer. We are more focusing on the recommendation. So we have used hybrid recommendation system. Our experimental results showed a hit ratio of 4%, which is big achievement for hybrid model. Later in the previous paper, it was less. We have referred this paper for developing the system. I would like to thank all the entire team of ICT4SD for giving us the opportunity for presentation. Thank you. Any questions, ma'am? Any questions?
Thank you, Lakshmi. Thank you.
Thank you so much.
Thank you, everyone, for your presentation. Just a minute. So we have come to the end of the session. I sincerely thank all the presenters for their excellent presentation and contribution, and all our participants for being a part of this conference. I hope this session was informative enough. And I, on behalf of the entire team, thank you for the support during this 8th version of the conference. And we hope to see you in the 9th version as well. And all the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already been forwarded to the Springer board, and the publication will be live within 6 months. Okay, so kindly cooperate with the team of ICT4SD 2023. I also thank our session chair, Astha Parekh, for your contribution, ma'am. This is a token of appreciation from our side to you. Thank you so much. I request everyone to just on their cameras for a quick snapshot, please. Just waiting for others. All right. Okay. Thank you, everyone. See you. Take care.